Hi everyone, this is Mrs. Lee from Todd Beamer High School, and today we are in Appendix B Activity 11. And so if you have not done so already, please try it out. And if you don't remember exactly how to write this, the line of, well, the equation of a line, I should say, here we go. So this is a brief little recap here. So remember y equals mx plus b. So if you remember here, your m, this guy right here, the coefficient of the x, so the number in front of the x, this is your slope. And then right here, this plus b, I like to include the plus, because if this was a minus, then it would think of it like a plus negative. So it would make it a negative, yeah, so it would be negative. So if it was a minus like 5, that would mean that this would be a -5. So I always like to include that plus in there. And then that would be our y-intercept. So this is y-intercept. Nope, can't spell it apparently. So this is why this is called the slope-intercept form, right? Because there's a slope and an intercept. The y one in particular, don't ask why. All right, so knowing that now, maybe you can try some of this other stuff. So try 1 through 5, I believe it is 1 through 5. And if you still, you're like, I'm a little, so then work with me, right? Let's do it together. So let's try this out. So again, the anything that I did not highlight, that is going to stay exactly the same. All right. It says write the linear equation of a slope of 1/2 and a y-intercept of -6. So here you go, y equals, now our m is that slope right there. So here's 1/2. X, because notice I did not highlight it, so it's still X. So just be careful when you do the X, when you have a fraction, do not put the X down here by the 2, because that's a completely different equation. Okay, so you don't want to put it below there. You want to do this, where it's like right at that middle area right there, right at that fraction bar. That's where you want to put it. Or you could put it on the top. I always opt to make it centered like that. And then our y-intercept is going to be -6. So a couple different ways to do that. You could go plus and then go -6 like that. But he wants a plus and a negative, right? Because what is a plus and a negative? Same thing as minus, right? So that's why for me personally, I just include that plus in the highlighted section, right? Because we normally would just write that as -6. All right. So that's the equation right there. So y is equal to 1/2 x minus 6. All right, so moving on to number 2. So we'll write the linear equation of the given graph. I do not know why that's a question mark. We'll just kind of erase it. That doesn't belong there. And so I look here, and I'm the easy one here is to find the y-intercept, right? Because I can just be like, oh, y-axis, y-intercept, right? See, that's why it's called the y-intercept. So that's where it crosses the y-axis. It meaning the graph, and the graph meaning that blue line. Okay, this whole like grid here, we don't call that, well, I mean, I guess you could refer to it as a graph, but yeah, so I'm referring to the blue line here. Okay, now, so that's going to be at +2. So I'm going to just put +2. And then I'll put my other, so y equals, and I know it's going to be something with an x, right? I just don't know what that slope is. So I'm going to kind of leave that blank for right now. And let's find a slope. And the only way to find slope, remember the slope is just how tilted a line is, right? And when I say tilted, I don't mean that they're mad, or maybe they are, I don't know, right? But we're just talking about how slanted it is, right? I like tilted, right? So I like to find another point on here that's like nice. Like this is, I mean, technically this is a point on the line, but like, what is that exactly? I don't know, right? So we're not going to use that particular one. So I noticed that there's one right here. Ooh, this is a nice point on the line, right? And so this is the way we've determined that we're going to find slope. And so it's just a ratio as from the vertical and the horizontal, right? So some may know it to be, I'm going to just put a little thing here, rise over run. The more official term would be like, not term, but like official way of saying it's like the change of y over the change of x. So this delta right here just means change. That's what somebody had said it was going to be, and so that we call that change. It's like the Greek letter for delta, right? For D, our letter D, right? So anyway, so it's the change of y over the change of x. basically we just want to know how much is the y changing. So I like to always start at the bottom, the lower point. So this one right here, the one that I just found is a lower point. And so I'm like, okay, well, look at the y, and the y is this up and down. Well, how much do I have to go up? Like giving directions, right? You go 3 blocks up. This is like +3. And you go 2 blocks to the left. So that's, remember, left is negative, right? So -2. So again, I always like to start with from the lower one. You don't have to, you could start with the higher one. It does not matter, right? So either way, it's going to give you the same thing. So here we would say our slope is 3 over -2, or we say -3 over 2. Okay, notice that the negative is on the outside like that. It's neither up on top nor on the bottom, kind of like our x, right? Neither on the top or on the bottom, right? We're just gonna let it hang out there. So that's gonna be -3 over 2. And if you remember, I said it doesn't matter if you start on the higher point or the lower point, it'll give you the same thing. And if you're like, are you sure, Miss Lee? Watch. Let me use green. So if I start on the top point, and I'm, again, it's like giving directions, right? So we're like, oh, you just go 3 blocks down, right? So that would be -3. And then 2 blocks to the right. Now going right is, or for you guys, it would be right? That would be +2. So that's going to be, again, the up and down first. So that would be -3 over +2, which is, again, -3 over 2, right? Do you see what I'm saying? Same thing. Does not matter which way you go. Usually people think of rise as going up, but you could always go, there's a rise and fall, okay? And that's why I usually start on the bottom one, just because you can always rise. See what I'm saying? But up to you. It is up to you the way you want to do that. Just make sure you don't do x over y, because the mathematicians have all decided just that, agreed upon that it's going to be y over x. Why? I don't know why. Just as y over x. We're not doing x over y. That's just how we've decided to do it, so that if you were to give this to somebody else, they would graph it the same way. Okay, we need to have some rules and orders here. So there's number 2. Let's see here. Write the equation of the line in the data table. Okay, so we're going to just cross out that question mark there. Let's take a look. So here we have lots of points. We have 1, 0, 2, 1, 3, 2, and 4, 3. And if you remember, right, just like how we did these points, you know, what's the difference of the y over the difference in the x? Right, I'm going to just pick any of these 2 points. So I like to pick, well, these 2 look kind of interesting. So from 3 to 2. So 3 minus 2, because what is that difference? Right, just 1, right? So 3 minus 2 is 1. All right, and then I'm going to go in the same direction. I'm going to go 4 minus 3. Notice I put an arrow this way, right? Whichever way you put the arrow, it just needs to be the same for both the y and the x. So you can't like do, oh, I'm going to subtract the 3 minus the 2, and then I'm going to go 3 minus 4 here. Can't do that. It has to be the same direction. Okay, it's like starting from the bottom point for the rise, and then going from the top point to the bottom one for the run. Like, do you see how that makes no sense? You can't do that. It doesn't work like that. Okay, so we are going to just stick with one way. All right, so the 4 minus 3, let me stick with my green here. So 4 minus 3, which is, again, still 1. All right, so this, again, my slope is going to be my change of y. So that's going to be just 1. It's 1 over 1. Look, what is 1 divided by 1? Just 1. Oh, yay. All right, so now let's write this down. So y is equal to, so we know our slope, which is 1, x, and then our y-intercept. If you remember, our y-intercept is when our x is 0. So notice we don't have when x is 0, but we can figure this out. Okay, we can reverse engineer this. Okay, if it was 0, what would it be? So here, remember, it looks like we're going up by 1s. And here, we're going up by 1s as well, which means that if it was 0 here at 1, 0, then what was it before that? It would have had to have been -1, right? Because -1 plus 1 is 0. So then this would right here would be our y-intercept. Because guess what? On the y-axis, what does x equal? X equals 0, right? And that's always going to be true. Just saying, it'll help you in the future. All right, so my y-intercept here is going to be -1 or -1. All right. You may think, well, do I really need that one there? No. So all teachers will know that if you write this down, if you write it down like that, they know that you know that that's just a one in front. They assume that, right? That the coefficient is 1. Okay, if you're like, no, I'm a little nervous about it, I still want to put the 1 there, totally go for it. But what's 1 times x? Just x, right? So that's why. So yeah, you'll get used to it. So now a car is traveling at 45 miles per hour. Write an equation that models the total distance d traveled after h hours. No, this is basically the dirt formula. I like calling it the dirt formula because literally it looks like dirt. Okay. And if you know what I mean, distance is equal to rate times time. See, dirt. All right, the dirt formula. So distance, and a lot of you guys do this all the time in your heads. If you're like going on a long road trip and you guys have been going like 60 miles an hour for like 3 hours, how far did you guys travel? Right, and assuming there are no traffic, no, so this is obviously not in Western Washington, but there's no traffic, then you're just going at a constant 60 miles per hour because you don't want to be pulled over, right? Because that would be bad. And how long did you go? And a lot of people would automatically go like, oh, 60 times 3, which is 180. Or maybe you need to calculate for that, whichever way. But you know what I mean? It's 180 miles, right? And that's exactly what this is. You all know the dirt formula. You just didn't know that you knew it. And you probably didn't know it was called the dirt formula. Anyways, so here we go. So distance equal to rate times time. And here we're just going to plug in the 45 miles per hour, which is our rate, right? This is our rate. So this is going to be equals 45. And then we say D, yeah, and they call distance D. So we're going to keep that as D. And 45, and instead of T, which is our time, is just going to be H because they're saying after H hours. So it's going to be 45H, just like that. There is no y-intercept technically. Well, the y-intercept is there. What would that be if there's nothing there? It's just +0. So do we need to really write that in there? No. So this is, that is unnecessary. We'll just erase that. All right. So the question in number 5 is, in the 4 above problems, which linear relationship has the greatest rate of change? And if you think of the greatest rate of change, that is, the change, remember the change of y over change of x? Yes, it's that rate, right? And that change. So this is talking about our slope. Okay, so our slope, which is m. All right, and in this case, well, it's kind of a no-brainer here because we have a 1/2, -3 over 2, 1, and then we have 45. And if you wanted to write that as a fraction, it's 45 over 1, right? Which means, yeah, which one's the biggest? It's definitely our last one, so our number 4. Where's my mouse? Here it is. So it's number 4, where the slope is equal to 40. I'll get there, 45. All right, it was great seeing you guys, although technically I didn't see you, but if you see me, say hi. Good luck and do the rest of the problems. All right, just gotta turn this off.